I waited outside. I took it remote. I wanted a bed. Tell the story or it goes. Tell the story or it goes. Full time, you talk your money up while it's living in a coal mine. Took time to call your ma. Hey ma. Told folks you know you mope it up. Well, you wanted it to hold that. You're back and forth with that. I waited outside. I was toking on dope. I hope that it'll go in a minute, like the past that you know. I wanted all that mine, sugar. I wanted all mine. I had to have it mine, sugar. outside. Then you took me in the room, and you'd offered up the truth. My eyes crawling up the window to the wall, from dusk till dawn. Let me talk to them all. Full time you talk your money up, while it's living in a coal mine. Told time to call your ma. Hey ma, hey ma. Told folks you know you mop it up, but you wanted it your whole life. You're back and forth for flight.
All right, welcome everybody coming in to present, plus teammates to support. For those of you watching on the live stream, I actually don't know how many people are watching the live stream. It could be 5, could be 500. I don't know. But regardless, for those of you watching on the live stream, we have our judges in another room who are just getting acquainted with one another. We have our presenters now in the main room, on mute. And for those presenting, we will actually be getting started hopefully in the next 2 minutes. But of course, the judges, we just got to make sure they're all prepped. So for now, hang out, chill out. For those of you watching the live stream, if you need to run to the washroom, do anything before you come back, we got a couple more minutes before we get this party started. And then hopefully I'd say we'll get the first presentation started 5 to 10 minutes after the hour. So anyways, until then, we'll see you guys.
Yeah. लगता है ज्वाइन करो.
I've been waiting in the sunshine, looking round like a storming, drying out like a histamine. I'm the warden on the front line, the yellow soldier on a dead mine. Listen, lover, won't you call me? Well, I'm a sucker for some harmony. When do I begin? When do I begin to end? When do I begin? When do I begin to? Say I've been waiting for you. Know the road gets hard, and you just wanna leave. I ain't never too far. Just have a little faith in me. When all the fears you have are all you can believe, oh, I'll be standing by your side. Just have a little faith in me. Have a little faith in me. Just have a little faith in me. Have a little faith in me. Just have a little faith in me. 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 Just have a little faith in me.
When you don't know who you are, I will find you so easily. Don't you worry, whenever you need me, have a little faith in me. 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 Faith in me.
All right, everyone. We're about to bring the judges back, but as Jenna is doing that, I wanted to check in on one thing. For anyone here, whether you're presenting or not, as a reminder, in a good presentation, in TKS, how do we start? What do we start with? Jamie?
An introduction of like just a quick introduction of yourself,
Yeah. Quick introduction of yourself. Why? Why is that important?
because usually the judges don't know who you are starting off, and it's quite professional to introduce yourself at the start.
Yeah, exactly. I don't know who you are. And again, this doesn't have to be something you guys have prepared or thought over too much. Just tell people who you are. What are you working on? What are you interested in? Who's on your team? It's probably a good thing also to introduce. And what it does is it lends itself to going into your presentation really smoothly, right? You don't want to be like, hi, my name's Jamie. I'm really interested in blockchain technologies. I minted over 1,000 NFTs on the Solana blockchain, and I'm actually looking to join some new projects. Oh, good. Okay. And now I'm gonna start my presentation, right? That's not how you do it. Instead, you talk about yourself, and then you just keep talking, and you just kind of go into your presentation. If I was to do a talk in front of a big crowd today, that's exactly how I would start it, right? I would start by introducing myself, talk about my background, talk about what I'm interested in, and then I would basically just transition to talking about the presentation. It helps to also keep you guys comfortable too, so you don't feel like there's this stark contrast between the real, just you talking, and the presentation side, right? Make sense? Easy stuff, right? Okay, well, with that said, I think the judges are gonna pop in about 5 seconds here. Perfect. All right. So now that everybody's back, I'm gonna get the music off. I'm gonna stop sharing my sound. I'm only gonna say a couple words. I'm gonna pass it off to Jenna, who's basically been leading this whole Moonshot project and arranging all of our lovely judges to be here, but also just making sure that this whole system runs smoothly. But the only things I really want to say for today, for those of you, of course, who are presenting, this is a little bit for our judges as well, is that make the most of the time you have today. I'm sure you're all terribly nervous to be here, but know that all of us here, that have been a part of helping you guys get here today, are so excited for the projects that you guys have completed. Jenna actually texted me last night, late at night, after going through some last minute coaching, as you guys know, on the presentations, to just comment on how crazy it is for her to watch how much you guys have grown from day one in TKS to where you are today. And I would say the exact same thing. It is amazing to see how much you guys have learned and grown through this process, and just soak up as much as you can in this moment. Know this is what TKS is all about. All those nerves, all those funny feelings. That's why you applied to TKS. That's why you came here. And the more and more that you're doing this, the better and better you're going to get at it. And the more and more you can have an impact when you leave our organization as well. With that, best of luck, of course. And now over to Jenna.
Yeah, we're so excited for you guys, and so excited to have our judges here as well. I'm going to briefly introduce them. And before I get there, just a little bit about how this works. You guys have done this before already, but you all have 5 minutes to present. And then the judges will have 2 to 3 minutes to ask questions. And then we'll go and deliberate, and then we'll decide the winners. And little plot twist, we are going to have some TKS swag for the winners. So no matter where you are in the world, we will send you some TKS swag for the person who gets best overall. So to just recap on what's at stake, these are the awards that are going to be happening. So we are going to do a best overall, and then we're going to have sub awards of most impactful as a highlight and a best presentation as well. So that's what the judges are going to be looking for. They have a whole rubric that they are using. And so that's what they're going to be asking questions about, so that we can come to a decision of the winner. So I wanted to give a brief overview of who we have joining us here as judges, and then they have a couple words for you before we get started, and then we're going to get right into it, and we're going to try to keep this moving pretty quickly so that we don't go over time, and so everyone can stay engaged and participate. So here are our judges today. We have Meredith from Walmart. We have Jared from Dow, who is really into circular environmental and climate change, which a lot of you guys have a big interest in. We have Robert Chong, and we have Sorab from Interact. Robert Chong is from Desjardins. And you can see a little bit of their bios here. I shared these yesterday as well for you, so you should be familiar with them, but wanted to give them a quick highlight and just say thank you guys so much for joining. Everyone is very excited to present for you, and so excited for your questions. And you bring a lot of value to be able to give teenagers the chance to be in front of multi-million-dollar companies, and so much experience is a real gift for them. And so we really appreciate your time. And I asked the judges if they wanted to say anything briefly before we get into the moonshot. So judges, if you have any words that you want to share before we get into it, what you're looking for, what you're excited about with these presentations, please do so.
If I might start, I would just thanks for everyone for coming. I can't wait. The most important thing is that for students like yourselves to be so steeped into trying to find solutions to major problems in the world, and looking at problems as an opportunity. And that's what I'm looking for, where we can solve problems and create opportunity. That's what the business world does today when it's at its best. And I'm hoping to look for that from all of you. Thank you.
Yeah, sorry, go ahead, Richard.
Oh, thanks. So my name is Richard Chong. Nice to meet everybody here. And I'd like to echo Jared that that solutions are what we're really looking for here. Problems are never really problems. They are opportunities, and how you approach it, how you solve it is something that's of great interest to all of us here on the judging panel, I think. And it's great for us to be here, and thank you for taking time on your Saturdays to join us. Really looking forward to see and hear what you have to say.
I'll just add a quick thing to what Richard said. I think bang on, there are a lot of complex fundamental problems still to be solved, and I've always found that students have a very unique and fresh perspective on how to approach and solve them. So I think that's something that I'll personally be looking for as well. Like, what's the perspective you bring, and how do you approach some of the most complex problems that we face today?
Wonderful. All right, let's get into it. So our first team that's coming up is Shruti, Emily, Janie, and Emily with Repairx Labs. So our screen sharing is on. So you guys can jump on to the stage. We will spotlight you, and then we will spotlight the judges again when we go to question asking time. And you can start whenever you're ready. I'm going to have my timer, and then I'll start playing music if you're going really over, and then you can it'll be like the Oscars. You'll know your time is done.
Can you use my screen?
Yeah, looks great.
All right. Right. Hi, my name is Emma, and I'm a grade 10 student as well as a TKS innovator interested in BCIs. My team, Janie, Shruti, and I are super excited to be able to share our moonshot idea with you all this morning. Let's get right into it. We as human beings are creatures who move. We run around, walk places, all while exercising our motor abilities, the use of our muscles to perform movement. Because movement is such a big part of our lives, we don't think twice about it. It just comes naturally. But what if I told you that 10 million people suffer from a disease that has the potential to rid them of that ability to move? 10 million people suffer from Parkinson's disease, and it's not even the only disease that causes this lack of movement. 50 million people worldwide suffer from neurodegenerative diseases, limiting their motor movement, to which there's currently no cure. Scientists have tried for decades to solve this problem. One method they use is dopamine agonists, but this doesn't solve the problem entirely. They've also tried using deep brain stimulation involving electrical signals to help reduce symptoms. This didn't work either. The reason why both these methods have not been successful is because they don't target the root cause of the problem, the fact that dead neurons in the central nervous system simply cannot regenerate because of the environment surrounding the central nervous system. It is inhibitory to axon growth, but we can change that. Essentially, we are transforming motor rehabilitation by restoring neurons. That is the vision of Repairx Labs, a company we have founded to bring this new transformed solution to life. Our solution is founded upon two major discoveries and innovations. The first is an experiment done on rats. Scientists removed some of a protein called syntophyllin from their cells and found that the rats were better able to recover from spinal cord injuries. So all we have to reduce is syntophyllin, right? That's it. Sadly, no. There are two major problems that were found in the experiment. The first was that scientists needed a much more accurate way to reduce syntophyllin without removing anything else from the cell. Second, the syntophyllin from the cell cannot be entirely removed because it is still needed for cells to connect. Our solution solves both. Before we get into our solution, we need to explain more about why. Why do we remove syntophyllin? Well, in nerve cells, mitochondria are anchored to their spots by the protein syntophyllin. If an axon is injured, the protein prevents the mitochondria from moving to damaged areas. But like I said before, we can't reduce all of it yet. Our solution is composed of three major parts. The first is getting stem cells, either embryonic or induced, will work. The second is editing those stem cells using CRISPR, a newly developed gene editing tool to reduce syntophyllin in the cells with accuracy and precision. And lastly, we would transplant the stem cells back into the patient. The original experiment with the rats, the researchers had directly used specialized cells from the rats to reduce syntophyllin, but we thought of the idea to use stem cells instead. Stem cells are not yet specialized, so they have the incredible ability to become specialized into any cell that is needed by the body. So stem cells are known for their ability to adapt, grow, and connect with other cells no matter where they are needed. It is this ability that we hope will allow them to connect with other nerve cells even without the protein syntophyllin being present. We will obtain the stem cells from temporarily removing blood from the body and separating the stem cells and blood before returning the blood back. Accuracy is a huge part of this idea because we are working in such a micro setting. Our solution uses CRISPR off, which is a variation of CRISPR that can turn off a gene. This is done through a process called methylation. Chemical tags are added to certain parts of the DNA so RNA polymers can create proteins from that gene. This is applied to the SNPH gene, which is the gene that produces syntophyllin. To administer cell transplantation, cells can be delivered through a needle into deep targets. For Parkinson's, that would be the putamen, which is the outer part of the lentiform nucleus of the brain. With this idea, Repairx Labs is hoping to treat motor rehabilitation patients, improving their quality of life. Our next steps as a company are to build labs and hire doctors and researchers from the fields of biology and chemistry to develop our solution before commencing clinical trials. Lastly, as a company, our main priority is to make this treatment accessible to all people who suffer from this disease. We plan to partner with government institutions and major parties like the United Nations to ensure that this treatment is accessible to everyone on planet Earth. Before we end off our presentation, we would like to give special thanks to Harrison and Jenna, as well as the TKS community, for supporting our project and fueling the ambition needed to complete it. We are also very thankful to Dr. Zhu Hengsheng and Dr. Xiaoming Xu, who pioneered the rat experiment our solution is based on. Thank you.
I wish we could have live applause right now because you deserve it. Thank you so much for sharing, Emma. Really appreciate your presentation and everything that you shared. And I'm going to hand it over to our judges. And so we'll get you guys on stage and spotlighted so that you can ask some questions. That was a timer because you were well timed. And so if judges, if you have any questions that you want to ask, feel free.
Thank you, Emma and team, for that amazing presentation. And also, it goes without being said, we can see a lot of the work and research that you put into all of that. So very well done. Out of curiosity, what do you guys see as the 3 biggest risks or one big risk with what you would be proposing as part of that company?
I can see if I can speak for my team, but one big risk that we think might happen is that just the research that needs to go behind this, because this is very experimental. There is nothing that says this cannot work, but we aren't really sure if it will work because it hasn't been experimented on before. And then, like with most clinical trials, we would need to start with animals like rats before we go into human clinical trials. And then we have to get stem cells for those rats, which might be pretty expensive. So the big risk would be just like the experimentation part of it.
Where did the initial idea for, I mean, you picked a major challenge, right? You picked a debilitating disease that impacted millions of people. But so where did the inspiration come from this? And then, and not so much on, you know, why you picked that, but for the solution. So that you've picked this neurological path to fix the challenge. So I'm curious where you got inspired to follow that particular path.
Right. So at the beginning, we were looking into neurodegenerative diseases as a whole. And then we realized that with Parkinson's, which is like a huge neurodegenerative disease, that this motor movement part of the problem is lacking solutions. So we thought we'd go there. And from there, we found that experiment that I mentioned with the rats and how their cells cannot connect, even with the reducing cytopilin, which is why we inserted stem cells.
Thank you.
I have a quick question. First of all, I think this is a very complex problem, and it's great that you're looking at a disease that's affecting so many people. I'm curious about the approach. Are you guys looking at it as targeted towards one particular condition, or are you guys also looking at solutioning it as something that's a bit more generic? For example, like mRNA, it can be applied to multiple things. And the reason I'm asking that is because, like you mentioned, there is a lot of cost that goes into R&D. And so if you're able to apply that research to like solving multiple conditions, then it allows you to make it more accessible to people and more available easily at a cost that's affordable as well. So have you guys explored that? And if so, how are you thinking about that?
Yeah, so we do plan on generalizing. Like mentioned, Parkinson's isn't the only disease that affects motor movement. And we started with Parkinson's, but the main problem that we are solving is the fact that the central nervous system cells cannot regenerate, which is a problem in so many diseases and so many medical mysteries. So we do plan on generalizing.
Perfect.
Wonderful. Any questions?
No questions from me. I'm just a comment. I'm impressed at the depth of research that's gone into this, And for somebody in grade 10, I would have expected this honestly from somebody more in sort of second year university in the neurophysiology course or something. So well done.
Thank you.
Wonderful. Thank you guys so much for your great questions. And Emma, thanks for sharing. I agree. It was really wonderful to see how you went so technically deep in this presentation. So really appreciate you sharing. We are ready for our next presenter, which is Gymnestic. And I believe Isha is going to be presenting. That's correct, right?
Yes.
Great. Wonderful. We will get you on the stage and then you will be able to present whenever you're ready.
All right. Is my screen visible?
Yep, looks great.
All right, so I'll start now. Hello, I'm Isha Noor. I'm a 16-year-old DKS innovator from Pakistan who's interested in artificial intelligence and machine learning. Today, I'm here as a member of a company, Gymnestic, which is trying to modify crops to feed millions in order to solve the world hunger. There has been an increasing rate of floods in India due to global warming, with around 4.8 million people in India exposed to the floods. And we cannot solve the world hunger without fighting the effects of floods on agriculture and crop cultivation. Because around 8.5% of the total agricultural land in India has been rendered useless from 2017 to 2019 because of the floods. And if this 33 million acres of land is brought under cultivation, it can feed approximately 76 million people in India on rice annually, which is absolutely crazy as it can solve 9% of the world hunger. Now floods destroy crops in two ways. Firstly, by washing them away, which is very destructive. And secondly, by reducing the crop yield, which we are currently working on. The crop yield is reduced because of limited diffusion of gases like oxygen and carbon dioxide, which are essential for the internal mechanism of the plants. In addition, the light transmission is also hindered in submerged water condition during the floods, which results in often low or high temperatures, both of which contribute to lower crop yields and causing food instability. The solution to this is stem elongation, allowing the plants to keep some of their foliage above the water level so they're able to absorb sunlight directly from the sun and allow faster diffusion of gases. The natural process of stem elongation in plants is basically the buildup of ethylene because of the limited diffusion of gases in submerged water condition. This stimulates the production of a hormone called gibberellin, which is responsible for the stem elongation in plants. However, the problem is that the production of gibberellin alone is not sufficient to achieve the required stem elongation to survive the floods. The farmers in India have found a way in which they're using mega sub-1 varieties of rice, in which the plants use a dormant or energy conserving strategy to survive the floods. This involves controlled metabolism of enzymes such as amylase, and this helps the plant to survive on limited supplies of sunlight and oxygen. Again, the problem over here is that the crops cannot survive if the flooding prolongs to 2 to 3 weeks, and this does not completely solve the problem. Therefore, we are introducing genetic modification of the crops to produce flood-resistant crops by essentially modifying two genes, ACE1 and DEC1. Both of these genes are present in rice and sugarcane, and we'll be focusing on these two crops. According to a research conducted on the working of these two genes in Nagoya University in 2020, it interestingly found that the working of the ACE1 gene is much more effective in the deep water rice, whereas the working of DEC1 gene is much more effective in the paddy rice variety. And the experiment proved that if ACE1 gene is specifically triggered or activated in deep water rice, it helps the plant to achieve optimal stem elongation to survive the floods. Whereas if only DEC1 gene is triggered in the paddy rice variety, it does not have any significant change in the plant elongation, whether it results in lower stem height. This proves that ACE1 gene is required for the stem elongation, whereas the DEC1 gene, on the other hand, is counteracting and suppressing the stem elongation. On the basis of this, we are optimizing the ACE1 gene, whereas suppressing the DEC1 gene in flooded conditions by genetically modifying our crops. And this genetic engineering is taking place instead of the traditional plant breeding methods because they're inefficient and time consuming. We're using a new technology called CRISPR, which is very time saving, and it only takes 140 weeks as compared to the normal genetic modification, which takes about 10 years. And the use of CRISPR involves a guided RNA and a protein called Cas9, which will be infused into the genome of the cell and which will modify the crops. The resultant crop will then be crossed with the original species of the crop so that the DNA is transferred to them as well. And this is a very time-saving and cheap solution. And this solution has been validated by Richard, who is a plant breeder and geneticist at an African university. And a big shout out to my team, Eli and Adelia, who worked with me in this amazing problem. And we were able to produce a solution which, if successful, can feed around 76 million people in India. Thank you.
Wonderful, wonderful. I'm giving the clapping emoji for you, Isha. Thank you so much for sharing. And I see the clapping emoji with a few other people here as well. And so judges, as soon as you get on the stage, feel free to ask your question and we'll get right into it.
So thank you for that, Isha. That was another very interesting presentation. How would you propose to do the development of the gene sequencing, CRISPR and so forth, yet have the plants available to be deployed in the geographies where they are? For example, do you intend to do the research over here in Canada and North America, but have the plants available in Southeast Asia where rice is mostly grown?
We plan to do it in South Asia because we found some of the institutions over here. Like one of the institutions is Assam University in West Bengal in India, and it is has a lot of capital and funds, and it has produced a number of rice varieties. And if we propose the solution to them, I think they'll be able to adopt it and research on it further.
Thanks.
Isha, good job, and nice, good presentation. Very interesting. You picked a really, important issue. Obviously, feeding people. When I look at things like, modifying these crops, this is an important issue, and there's companies multi-billion-dollar companies all over the world working on this. I'm curious if you looked at why no one's looked at this particular solution yet.
I think because generally drought is a much more prevalent problem around the world as compared to the floods. And in floods, usually the energy conserving strategy is much cheaper and is normally deployed. And because the flooding is a problem caused by climate change for a shorter duration, because eventually it will be just droughts. So I think that's one of the reasons.
Okay.
I have a quick comment. I come from a farming family in India, so I can totally relate to this problem. And one of the things I'd urge you to consider also, and I think you've done a great job analyzing the impact and how to solve the problem, is accessibility of the farmers, because the landholding size is 1 acre per farmer. And so for this to reach most of the farmers, you will need a channel that can give you access to those, fragmented farmers market. So have you thought about the distribution channel, or how would you get this to the end farmer where they can use it and kind of get the benefit out of it?
We haven't thought a lot about it, but we were thinking about deploying it with the help of the government, essentially. And proposing to them, because they have a lot of capital and influence over the normal and peasants, to encourage them to adopt it, maybe.
Yeah, no, that's one of the most impactful ways to get to the farmers, through the government, at least in geographies like India, for sure.
And not a question, but just a comment for the group, Isha and team, really well done. And overarching, I think what was very impactful about your presentation was you started with the problem, but you also said, if we solve it, this is what it could actually look like in practice, in the sense of that 9% being solved. So really well done. That was a great way to introduce a very large problem.
Thank you.
Wonderful. I see Adelia also smiling as your other teammate. So I'm sure she's cheering you on. Guys, thank you so much for such a great presentation and a great idea. And our next presenter that is on the stage is Wank, which is Rafa. And so Rafa, you can start getting ready. We will remove the spotlights and get you on stage. Perfect. Wonderful. Rafa, you can start whenever you're ready. Again, don't worry too much about timing. I'll let you know if you're going over.
Okay. Just a second.
Looks great.
Thanks. So hi, my name is Rafa Rahman. I'm a 14-year-old girl in Australia, freezing her socks off now because it's like 12:30 a.m. So it's like 9 degrees. But anyways, besides that, I'm really excited for this, and I know Mara, my partner in this competition, was also extremely excited for this. Unfortunately, she couldn't make it. So welcome to Wank, where your trash is our treasure. Our mission is to use natural resources to restore the quality of our land by 2030. So 2/3 of Australia's land is already degraded. Like, I could walk out and go on a walk for 5 minutes, and I would find somewhere like that, like a patch of like grass land that is quite nearly barren. Like, I can't grow, like me and my parents, we literally struggle to grow stuff on our garden beds because the soil is lacking nutrients. So think of the farmers who have to grow so much for like so many people, and how many people rely on that produce to live. And I'm afraid that maybe in the future, if we don't do anything about this problem, we might not be able to sustain ourselves as a society. So why Australia? Well, Australia feeds 70 million mouths across the world. We've already lost 13% of our native plants, and we are spending $1 billion every single year to like just combat the consequences of land degradation. That's like huge. So we've narrowed our the root causes down to drought and overgrazing within Australia, and the consequences are soil fertility declination, water, wind, and soil erosion, and soil salinity and acidity. So think of the environment like a cycle. So animals and humans, we put carbon into the atmosphere, and the soil, which is the second largest carbon sink, takes that carbon and stores it inside the soil, which the plants use to then grow. And then we animals and humans use the plants and land as a resource. But this environmental cycle is damaged, and this is largely due to mass agricultural practices that have damaged the soil, therefore producing less crops and affecting us in the end. So our solution is it will improve the soil quality using Wank mulch. Our mulch consists of four ingredients: crushed carbon captured graphite, dried grass clippings, biochar, and crushed limestone. But before we go into why these materials are so good, I want to take a step back and look at carbon capture. Personally, my favorite part of this whole presentation. So the process of carbon capture is you gather the air in these big, huge fans, as you can see in the picture, and then you separate the carbon through chemicals. One of them is, I'm pretty sure it's potassium hydroxide, and it becomes a liquid. And then through concentration, using chemical processes and compressing and heating the liquid, you produce graphite, which we'll crush and use further into the process. So the benefits of using grass clippings is that it's a sustainable resource. It gives the soil mineral and nutritional benefit when used, and it's eco-friendly. The benefits of using limestone is it increases the pH level within the soil, which Australia lacks, and thickens the mulch and prevents weed growth. The benefits of using biochar is it makes use of dead plants from bushfires, since they happen so much here. It enhances the nutrients and improves acidity within the soil, and no fertilizer is needed, just this one thing. The benefits of using graphite specifically is it cleans the carbon emissions from the air, since we're using carbon capture. It prevents water loss and better land fertility. So this impact, I don't think you guys understand how important land degradation is. It impacts every single aspect of our lives. The clothes you wear, the food you eat, the house you live in. If the land becomes degraded, then we won't have enough resources to create homes, and eventually land degradation could lead to speeds up climate change. So we won't even have an earth to live on. And think about the animals. This is their home too. With grass mulch itself, like plain grass mulch, you can improve the soil by up to 25%. That's a lot. And by incorporating graphite, limestone, and the biochar, just imagine how much impact you would have. So our validator was Vasal Toku, and he said this idea was a good idea because it would improve the state of land degradation in a natural way, which would benefit the land. There are potential drawbacks to every solution, and here are ours. This idea may be difficult to produce on large scale, and the current technology may not be efficient enough. But to help avoid those issues, we're introducing potential partnerships. Shell Energy and Leda are two companies within Australia that have already introduced carbon capture projects, which the government has, and the Australian government as well is promoting carbon capture to help combat land degradation, which is a huge issue in Australia. So if you're excited for this idea, come join us at Wank.
Wonderful. Thank you, Rafa, giving you another applause emoji. And we're going to have the judges come on stage. You can stop sharing your screen and get ready for their questions. And judges, as soon as you're on the stage, you know the drill. You can ask your question and get to know a little bit more about Wank.
So thank you for this presentation. It's a really interesting idea. So grass, limestone, biochar, and graphite. Just let me make sure that I understand it properly. You want to take these four components and incorporate them into degraded land. Is that the concept?
Yeah. Yeah.
Okay. And would that be like you spread this over existing land, or you need to plow the land and mix it all in?
We would just spread it on top. It'd be like a protecting layer over the soil.
Okay. And would it then be subject to drought conditions or rain conditions? Like how would the natural environment affect this incorporation of ingredients?
So the idea was that erosion was a huge one because of wind, soil, and water erosion. The land was constantly being beaten up, basically. It's not in a good state, right? So the whole point of the mulch is to provide a protection layer over the soil, which will also help add nutrients and help the environment recover by itself. Because why mulch is better than fertilizer is because fertilizer, you're basically just adding another top layer of soil, which you're not letting the environment do what it does, right? Whereas the mulch, you'll just be helping it. You'll be supporting it, basically.
Okay. That's interesting. Thank you.
No problem.
I'm happy that you were looking at potentially using a byproduct of the carbon capture process. Okay. I have no idea the viability of that, but I appreciate that you were looking at that. I mean, companies like the one I work for Dow, we're looking to do carbon capture and storage, but there's this dream of everyone wanting to, well, instead of just storing it, why don't you use it, right? If you're able to do that. And so I appreciate that you were looking at that. You know, when I was looking across some of the other, I mean, I want to look at one of the challenges. Did you get any assessment of how much biochar, and for example, is available? I was curious as to, like, is there a adequate supply of biochar?
Yeah, we looked into that, and so this was one of like the things we didn't really get to do. We didn't have as much time to like reach out to more people, see what they like thought of the idea, how much we would need of each of the 4 elements. But biochar was one of the like additions. So like it wouldn't be like one of the biggest elements, if it makes sense. Like grass would probably be like the biggest component, and then it'd be like the graphite, and then the limestone, and maybe the biochar would be added just to like use like what was left over of like bushfires to promote sustainability.
Thank you so much, Rifa, for your presentation, especially at 12:30 in the morning. But mind you, 9 degrees is quite warm in Canada, so I don't know if I feel that bad for you in that respect. But with your presentation, you mentioned someone who was helping validate what you were putting forward as part of your business. Who are they, and what credentials do they have that we should be mindful of?
So they work at a company in Romania, and the company works on creating solutions to agricultural issues. So they were able to help us and like give a little pointers about like what could work, what couldn't work, and yeah.
Perfect. Okay, thank you.
Yeah, I'll just give a shout out again for being up so late and still presenting the idea. That shows the passion that you have for this. And the fact that you also mentioned in the presentation that this goes beyond just the immediate problem and the impact it has on the cycle of the environment. I think that's something that makes it a good moonshot idea.
Thank you.
Wonderful. Thank you, judges. Thank you, Refa. Next team that is coming up is Cosmic. And so Mingao, if you're ready, you can take a couple deep breaths before we bring you on stage. And as soon as you're on stage, you can share your screen and get ready to share.
Yep, let me share my screen right now. Is this visible?
Yeah, looks great.
Okay. So, hello, my name is Ming Hao. I'm a current 9th grade innovator here at TKS, and I am also a co-founder along with Charlene of our company Cosmic. But more than that, I am also a space enthusiast. I love looking at the stars, but being a space enthusiast, when I was young, for all I knew, the sky wasn't blue. And that leads us to this picture right here. Here's my home city, Beijing. And this picture is solely due to the pollution that are happening in Beijing even right now. So that leads us to this problem of carbon emission. Globally, 43 billion tons of carbon dioxide are emitted annually. That means by the end of this sentence that I'm speaking, more than 15 million pounds of carbon dioxide are released into the atmosphere. So we had to switch to sustainable energy. We started looking into that. We have the 3 main ones. We have solar, wind, and nuclear, but they all have their respective problems. For solar, it's very inefficient. For wind, it's unpredictable and inconsistent. And for nuclear, we all know the tragedy that happened. It's very, very risky. If something goes wrong, then the whole area would be devastated. So it turns out we can't keep on relying on our current systems. We have to literally think outside of the box into the extraterrestrial world and into the realm of space. In space, Earth is constantly being bombarded by something called cosmic rays. Within these cosmic rays we have X-rays. X-rays occur in space because of all the crazy things that happen in space. It mainly originates from the sun, but there are other things that happens in space that also produce X-rays, like stars collisions and supernova stars exploding. All of these produce an immense amount of X-rays that hit the Earth. So why not collect the energy from this? In fact, X-rays are up to 400,000 times more energetic than visible light, which current solar panels collect. So from there, we present to you our company, Cosmic, a revolutionary sustainable energy source by harnessing X-rays. let's first look at our proposal. We propose to launch a satellite akin to this into space, into geosynchronous orbit around the Earth that's responsible for collecting X-rays, harnessing it, and converting it into energy and beaming it down at Earth for reuse. Let's look at step 1, which is concentrating these X-rays. To concentrate the X-rays, we've designed very, very special gold mirrors such that it is able to reflect X-rays at such an angle such that it's able to concentrate into one point. And this has been mathematically designed. I've done the mathematical calculations to ensure that this, in fact, does work. That leads us to our second step, which is converting this X-ray into energy. So at this concentrated point of all the X-ray particles hitting this point, we have something, a very, very special material called methylammonium lead iodide, which I will detail later. But this panel is what's responsible for converting all the X-ray particles into energy. And on the side, we have a microwave or laser transmitter that's responsible for beaming this collected energy back down at Earth for reuse. Here is a quick rear view of our satellite, which contains backup solar panels as well as thrusters to ensure that our vehicle can remain mobile and versatile at all times. So what makes our design different from all the other things that we're doing? Yes, there are research that goes into how gold mirrors can collect all these X-rays and concentrate X-rays. Yes, there are research that goes into talk about methylammonium lead iodide. But we're the first company, we're the pioneers that actually combine these ideas and send the satellite into orbit for something, for greater purpose, to bring us a clean world. And that leads us to the heart of the problem. What is this methylammonium lead iodide? Well, to understand that, let's first look at conventional solar panels. The whole idea behind that is that light comes in and hits electrons off of these silicon atoms, creating a voltage and creating current, and therefore powering millions of our homes. However, solar panels are actually very, very inefficient. They're limited by a limit that's actually capped at 30% efficiency. And due to our modern technologies, that's actually limited at 23% only. However, then we have a special material called perovskites, which has also been into development to be used in solar panels. These are actually can be way more efficient than solar panels, but also they have a very special property of being able to control the band gaps. And this methylammonium lead iodide is a type of perovskites that has the band gap to be able to harness these X-rays and to be able to convert them into energy. In fact, there has been research and a published scientific article that explores the potential of this methylammonium lead iodide of being able to operate in space. In fact, this piece of lead iodide has a 75% charge collection efficiency for X-ray particles, as well as a greater than 80% stability rate when operating in the harsh conditions of space, which is considerably high considering how extreme the conditions in space are. So we want to make it a real thing. What happens if we do make it a real thing? Although there hasn't been much research into this pioneering field, we know that for sunlight, or for solar power at least, it accounts for around 20% of the US total sustainable energy source. And this methylammonium lead iodide panel can only be more efficient than solar panels. So we can only go above and beyond that 20% limit if we're able to grow this industry and potentially revolutionize the sustainable energy industry. So how do we make this a real thing? How do we launch the satellite into space? To do that, we plan on partnering with both Caltech and Blue Origin. Caltech is actually working on the technology to send energy from space back to Earth for reuse. And Blue Origin, as another space company, shares the same vision as us to be a sustainable company. So with these two partners, we believe that we can make our project a reality. Time really is running out for our future to be in our hands. That leads us to our question: what is the true potential of humanity? So maybe we can take our next leap forward with Cosmic. Thank you, and here's the team behind the Cosmic.
Wonderful, wonderful. I tried to do the applause sound, but I can't do it while you're sharing your screen. But know that that is the intent here. Thank you so much for presenting, Minghao. Really, really great presentation. And as the judges come on screen, Mingao, you can stop sharing your screen
Mhm.
and they can get right to their questions.
Thanks, Minko. That's a very interesting proposal there. I like the idea using the gold panels to focus the X-rays on your methylammonium lead panels. I didn't quite understand the use of the microwave laser to beam the energy back down to the planet. Can you go through that a little bit?
Yeah, sure. So although it's not really the goal of our project, but there's actually a very specific group that's working on this technology. And the idea is that we use the energy harness from space, and then we transmit this energy in the form of laser or microwaves. And that's the transmitted signal is able to be received back on Earth. And that's actually able to harness the energy we collected from space and transmit it back to Earth. Caltech is working on it right now, and we do plan on partnering with Caltech to further this technology and implement that into our own systems.
Okay, so give it to me in a nutshell, though. You have a giant dish collecting the microwaves that you beam back from your satellites, and then what happens?
Right, so that the collected signals or the waves, the electromagnetic signals, will be collected into our energy. We haven't done much research into that perspective particularly. We've been focusing on collecting energy from space, but we do know that it's possible because there are scientists who are working on that aspects right now.
Okay, fair enough. Thanks.
Thank you.
Just Jared here from Dow, just kind of building on Richard's question. Is there been any estimates yet of, how much power actually could be generated from one of these per one of these units? So, we speak when we have solar installations, wind installations, nuclear installations, we speak in megawatts, right? How many megawatts? Has there been any estimates, have you seen, of that potential?
Right. So because this is such a new field, we actually tried doing the calculations for that, but we found very inconsistent answers. Some gave very little, some gave the huge amount of power. But I think the hugest validation that we have is research articles that actually explore the potential of this being able to implement into space. And the reason I think our project has such a big potential is that even if collecting X-rays is not enough, we can expand our project to collect light all across the spectrum, because we can just switch out the panel for something else and maximize its efficiency. So I think it has huge potential in terms of incorporating the space industry into collecting energy for sustainable energy reuse.
I have a question from the security point of view. It's great that you're sending the gold to the space and nobody can steal it. That's great. But this is a thing that could be potentially a more extrapolative security threat than even nuclear power plants, right? Because suppose all that energy that's coming down is targeted at a city or something like that. So in terms of translating that to the feasibility of this kind of a concept becoming real, how do you guys think about that?
Right. So in terms of the security, we're actually thinking about, first of all, for the microwaves. I think for the microwave waves, which Caltech is working on right now, I think not accounting for the laser potential, but the microwave, I think it can't do that much damage even if it is used as a weapon. But in terms of the security side of things, we haven't really thought about that aspect. But again, we will work with Caltech if this project does become a reality and explore all those potentials and areas of concerns of security and like all the other judges mentioned areas of concerns also.
Sounds great. Thank you.
And Minghao, thank you so much for the presentation, as well as to Charlene on your team. And really, mine's just more a comment than a question. I think what was really powerful about that is you anchored it with a personal story and showed a visual of the city that you're from. And one of the things that I've always found to be successful with presentations, which I think you did really well here, is the slides are Robin and you are Batman when you tell the story. So you did a really good job there.
Thank you.
It's a great analogy. Who thought that you were going to get a Robin and Batman comment today, huh, Mingo? You're a superhero in your own way. Amazing. Amazing. Wonderful. Thank you guys so much for your questions. Definitely lots more when we're thinking about brand new technologies. You did a good job of trying to articulate that, Mingao. So thank you. All right. We are on to our next team. Oh, Jared, did you have anything else you wanted to say?
No, I was just waving at the participant.
Okay.
Thank you.
Misinterpret that for a hand raise. That's all right. All good. So we'll get our next team on stage. This is Arabi, Arushi, Emma, and Jeannie with Repair or Repair. You guys can tell me how you say it correctly. When you guys get on stage, the stage is yours. Awesome. Emma, whenever you're ready, you can share your screen. Perfect. Great.
Okay. Hi, my name's Emma, and I'm an 18-year-old innovator, and I'm one of the co-founders of Repair, a company that strives to bring our Earth back to the way it started by removing air pollutants from our precious blue skies. Now, I'm here today pitching Repair's vision for the future, but the truth is no solution can be implemented in the future if there is no future to begin with. Being a part of Gen Z, it upsets me that because of air pollution, my future will be filled with droughts, dust, and even death. Air pollution is not just some problem, air pollution is a life or death situation. In fact, 1 in 9 people globally will die from air pollution, which means that about 2 people in this call here today will die from air pollution. And if you thought that was scary, think again, because in India, 2.5 billion tons of CO2 emissions are produced each year, which led to 1.7 million premature deaths in 2019. That's why at Repair, we want to create a world where no one is going to die from air pollution. So I present to you Repair's latest invention. Not only does it look like a real tree, it can perform the exact same functions as a real tree. Our solution uses direct air capture, which is a method of either capturing CO2 from the atmosphere or directly from the air. But the problem with this is that it is not cheap. First of all, because machines have these fans that use a ton of energy to suck in the CO2. And they use this sorbent, which is a substance that the CO2 can stick to. And releasing the CO2 from the sorbent requires a ton of heat. We're talking temperatures well above 900 degrees Celsius. So that's why we carefully crafted our solution to make it more cost and energy efficient than current methods. So the first part of our solution involves capturing the CO2 from the tree. How does this work? Well, the tree is composed of a series of leaves, and each of the leaves have this little individual sensor. And when the leaves detect that wind is blowing across them, a propeller powered by solar energy will spin in the clockwise direction, which will compress a tube, sucking all those nasty air pollutants into the tree. And once the tube is filled with air, the propeller will simply spin in the other direction to decompress the tube for future cycles. And then the CO2 will fall down the tree trunk until it gets stuck to the sides of it, which are coated in our sorbent of immunoguanidine carbonate crystals. And the rest of the air particles will simply exit through the top of the tree. But what's cool about this tree trunk is that it is made of glass, so it can act like a greenhouse. So when sunlight shines through the glass, it heats up the inside. And when temperatures reach 80 to 120 degrees Celsius, the CO2 will be released from the sorbent and will fall down the tree trunk through a filter, so it can become purified. And with our solution, whenever there's sunlight, there is clean air. Because as sunlight continues to shine through the glass, it will eventually hit a container containing water and platinum. And this reaction will split water into oxygen ions, which will flow up a tube connected to a branch that can be lowered for collection, and hydrogen ions, which will flow down a tube, leading to a container at the bottom of the tree. But in reality, a tree cannot be a tree if it does not perform photosynthesis, which is why in our solution, as the CO2 continues to flow down the tree trunk, it will be detected by a sensor, which will open the door to a container, releasing rubisco and water. And those three things will eventually meet in a container containing ribulose. And this will form a molecule called RUBP, which will then split to form a whole new compound called 3-phosphoglyceric acid, also known as 3PG, which will be in a container at the bottom of the tree to be collected just like the hydrogen. So not only does our solution help solve air pollution, it also produces valuable byproducts of oxygen, which can be used to purify the air, and hydrogen and 3PG, which can be used to make biofuels. And a single one of our trees can capture 30 kilograms of CO2 each day, which will allow us to capture CO2 500 times better than a real tree. So if you are as passionate as we are about solving the pressing issue of air pollution, what are you waiting for? Come join Repair and let's restore our precious earth together.
Wonderful. Thank you so much, Emma. Really, really great presentation. Thanks for explaining your idea. You can see my emoji here clapping you on. And as we get to the stage, judges, you guys can ask your questions as you're ready.
Well, thanks, Emma. I think that's a brilliant idea, actually. What are your estimates on how much a tree would cost, a robotic tree?
So we're not entirely sure how much the tree itself will cost, but we have a financial model that shows us how much value we would get from these byproducts, because although direct air capture can be quite expensive, by making these byproducts, we can actually make quite a bit of money off of it. So for oxygen, we researched this and currently it's valued about $2,400 per 2.8 pounds of it. And green hydrogen, which is hydrogen produced by renewable energy, is valued between $3 to $6.5 per kilograms. And 3PG is valued at about 635.25 for 1 gram of it, which we can sell to make money to account for the cost of the trees.
Okay. And what would be your model for collecting the byproducts of the trees? Would they be connected to each other by tubes, like the way that you make maple syrup, for example? Or would you need a truck or bike or some guy to walk around to every tree and, open the drawer and empty the stuff into a container?
Yeah, so to collect the byproducts, the oxygen flows up through this tube that's connected to a branch that can be lowered, and then maybe a truck would have to come pick it up, or we could have robots that could deliver it and sell it or disperse it into the air. And then for the 3PG and the hydrogen, it's located in this container at the bottom of the tree. So we were thinking of either pumping it underground and having it delivered through there, or having trapdoors that we can connect the tube to collect the byproducts of 3PG and hydrogen from there.
Thanks.
I think this is a very interesting idea, and one thing I'm curious about is how much densely would you need to plant these trees? Like in a particular area, would you need to plant them like, say, 5 feet apart, 500 meters apart, or 5 kilometers apart?
So we have the dimensions of the tree calculated, and we estimated that it will be about 10 feet in height and about 5 feet in diameter.
Mm-hmm.
And a single one of our trees can capture 30 kilograms of CO2 per day, because we're estimating that it could run through 5 cycles. And we were thinking of putting them in mostly countries like India, where air pollution is a huge problem. I'm not sure if we would need to place them so close together, because one tree can have so much impact to solve air pollution, which is why we try to make it as effective as possible to reduce costs, to make sure that we don't need to manufacture as many trees.
Yeah, so I think that's an interesting point, because you'll need to figure out, like, do you put them as far apart as a cell tower, or do you put them as far apart as a windmill? Because space is gonna add to the cost of like putting it where you want to put it, especially in a country like India that's so densely populated. Standing up a cell tower costs a lot. Like they pay a lot of rent to get that space where you put up that cell tower. So I think that's an important consideration as you think about like putting them in those densely populated areas? Like how far apart would you need to put one of these there?
Yeah, I think
That said, I think an interesting potential would be for a lot of cities to get into the robotic tree planting business. And I'd say it's an interesting way to potentially make the lives of urban dwellers more pleasant by having a bunch of air filters just lining the street that you walk down most of the time.
Emma, really well done. Your walkthrough, actually the full cycle of how this would actually work, was very, very impressive. I felt like I was watching a full engineer presentation on how this would work. Out of curiosity, what is the longevity or the shelf life of one of these trees?
So the tree is made of glass, so I don't think it would decompose in any way. And the sorbent, currently, a lot of direct air capture machines use a liquid sorbent, which requires a ton of energy to release the CO2 from. But the cool thing about our sorbent is it's a solid immunoguanidine sorbent, which we were advised to do by Rob Fraley, who is the head of carbon capture at Air Capture Co. And he said to use a solid sorbent because this one can be regenerated every time it's heated by the sun, which would greatly increase the longevity of our trees.
Great, thank you.
Just one last kind of, I guess, comment. I'm somewhat skeptical about direct air capture because it's typically very inefficient, right? So far, right? But people are working on it. I like that you've taken a different look at the idea. So I guess my maybe quick question is that how scalable do you think this is? So you talk about a small tree, right? Which I think maybe could have some, if a small tree with a lot of them across the city, maybe there could have a lot of impact, but could you make a really big tree too? Is there any scalability potential to this design?
Yeah, so currently there's a company called Carbon Collect that created a product called Mechanical Trees, which essentially is kind of like what we're doing, except it doesn't perform photosynthesis. And this one, because it only captures CO2, it can be 1,000 more times efficient than a real tree, but this one is 500 more times efficient because it can capture 30 kilograms of CO2 per day. And usually direct air capture machines can capture the smallest ones about 10 kilograms of CO2 per year, which is really not that efficient. And that's why with solar energy and our sorbent, we're able to capture so much more in a day and create much more impact.
Really great questions. And thank you, Emma, for answering all of them. I can tell there's a lot of interest about this. So appreciate everyone contributing. We have 2 teams left, and then we will be able to deliberate the winners from all these great ideas. So our second last team on the stage is going to be Capsulate, which is Rehan, Ishita, Utkarsh, Calypso, and Paniotis' team. And so whenever you guys are ready, you can get your presentation, take a deep breath, and you guys are going to be starting the final part of these presentations. So excited to hear what you guys are going to share. Rehan, are you presenting? Wonderful.
My name is Rehan, and I'm one of the 5 co-founders at Capsulate, the company I'm here to speak about today. Before we begin, I'd like all of you to think to yourself. Think about the food you've eaten today. Think about the food you've eaten yesterday, the day before that. Think about the variety you have in your fridge, in your kitchen, in the store right next to you. Think about how accessible all the food you need to stay healthy is to you. Now take a moment to be grateful, because a startling 40% of the world's population doesn't have what you have, the means to satisfy the basic need of adequate nutrition. All across the world, regardless of the walk of life, people aren't getting the nutrients they so dearly need. There's so many. The reason for this is an inability to afford a range of food to maintain sufficient levels of macro and micronutrients. However, even in cases where affordability is less of a problem, multiple other factors, such as a lack of information or time to maintain a healthy diet, are causing what can be labeled as effectively a global nutrition crisis. In the US, a staggering 90% of the population is at risk of at least one type of vitamin deficiency, such as vitamin D, mineral deficiency, such as low calcium or magnesium, or suffer from anemia. On a global scale, 45.4 million children suffer from acute malnutrition, resulting in wasting and significant developmental problems, with 45% of all deaths in children under the age of 5 linked with undernutrition. This is a devastating problem, with huge impacts globally. The solution is where we come in. We are Capsulate. We are working towards our nutrition-free vision for planet Earth, where humans are stronger, healthier, and happier, through our mission of creating personalized pills that will replace food, providing all essential minerals and vitamins for the human body to thrive, while remaining affordable. This is how the Capsulate system will run. Our ecosystem is made up of 3 components: the app, the pills, and the machine. Each element serves a specific yet vital role in ensuring nutritional needs are met to the highest degree of accuracy. Firstly, the app. Our app will serve as the method of communication between the user and our pill production technology. By collecting vital user metrics such as age, weight, height, average calories burnt per day, etc., our software will be able to create a personalized plan for the user, similar to how a nutritionist creates a diet. If need be, a blood test could be conducted to measure specific nutrients in order to assess the deficiencies. Based off of this data and the gulf between the user's current nutritional levels compared to ideal levels, a completely pill-based diet or a hybrid diet plan will be generated. The app will also serve as a platform for tracking progress as well as managing pill supply. Onto the capsule itself. Specific pills will cater to specific nutrients, made in required amounts to be combined in order to satisfy each customer's nutritional needs. The step to produce a pill, in this case for vitamin K, are as follows. We use an ingredient with the relevant nutrient, in this case, broccoli florate. We air dry it to remove moisture and lock in the nutrients. We then turn the air dry product into a powder that can be used. Based on the metrics provided by the user, our 3D printer adds corresponding amounts of this concentrate and encapsulates it in an edible capsule. The average person on a Capsulate diet would consume about 100 food pills a day in 5 meals, followed by a dinner of their choice under 1,000 calories, because who doesn't love eating mom's food every once in a while? Lastly, the final element is the capsule producing machine. Initially, Capsulate will create pills in warehouses or stores or factories and ship supply to customers regularly. But as we expand, we aim to introduce a personal pill producing machine, which will only require the user to purchase ingredient cartridges from us. Initially, we can expect pricing of a Capsulate diet to look something like this, with prices at similar levels to the average American's cost of food today. However, as we expand and more efficient methods of capsule production are developed, we can expect these costs to reduce significantly. Post R&D and initial trials, we will begin services with a pilot program, carried out on 30 people across 3 different age group sectors from different backgrounds for 3 months. In this period, we will carry out general checkups at regular intervals to assess efficacy, and then based on data collected, improve and repeat to create a balance between optimized nutrition and consumer cost. After we are satisfied that this balance has been reached, we aim to launch by around 2026 in select regions, targeting the middle and upper class, who will be able to afford our current price point. In the 4 years post-launch, we aim to target a wider market and innovate on our existing technology to reduce costs as mentioned, in order to be able to cater to those who need our help the most. The impact is obvious. People who use Capsulate will benefit from lower blood pressure and cholesterol as their diet's being completely managed for them, and will benefit from a healthier, happier, and longer life. As Capsulate expands, we'll be able to carry out what we see as most important, to be able to provide affordable, effective nutrition for those who simply don't have access to it right now, enabling them to break out of the limitations that a lack of nutrition currently has. With your help, we'll be able to do just this and reach ever closer to our vision of enhancing human health and strength by eliminating malnutrition. Thank you for your time. My team and I will now answer any questions that you have.
Thank you, Rehan, and really appreciate your presentation. Judges, whenever you're ready with your questions, you can go ahead.
And really interesting presentation. I'm curious, what's your go-to-market strategy? How do you get this to customers?
Yeah, so as we had, as I mentioned in my presentation, but possibly not elaborated on enough, we will initially manufacture them in factories away from customers and ship them at regular intervals, perhaps on a monthly or, 3-monthly basis. But in the long term, we do aim to expand to create this machine that will be able to generate these pills that we can sell to customers in their homes, that they can keep in their homes. And then all they'll need to purchase from us is an ingredients cartridge.
So I'm Calypso and I'm also a part of the team. And on top of what Rayhan already said, we're really relying at first on piloting this solution, collecting data in order to be able to persuade consumers that this is a safe option that they can use and actually benefit from it and really change their whole lifestyle and their health, because like people are unable to design proper meal plans due to lack of affordability or due to lack of the ability to actually design all the food plans to secure vitamins, minerals, and all the other ingredients that we as humans need to function properly.
Thanks, Rayhan and Calypso. It's an interesting idea, and I could see that it has application in certain cases. More of a comment than a question, though. I appreciate that it's going to start off with the personalized app, so you can eventually make personalized pills. I think that's a great idea. But that is something that's aimed at people who can afford one of these. And that's great for a lot of people and not so great for probably more people in the world who don't have the money to actually afford one of these things. So I would suggest that maybe there's some thinking that needs to go in for the greater part of the world population who don't necessarily have access to phones and apps.
So
Yeah.
basically, a part of that about the financial aspect, we researched and we found that each person spends an average of $6 to $8 every day to eat, and our pill costs $7 per day. And the third, if you take for 3 months, there is also a discount. But we also identified that people, as you said, in least economically developed countries will not have the access to those pills. So that's why our thought for future prospect would be to collaborate with organizations such as the UN Department of Nutrition in order to provide these pills to people that are in poverty and cannot actually afford those. And also these are the people that actually have the most serious problems with the malnutrition because they are not nourished enough to sustain their body.
Yeah, I would encourage you to keep pulling on that thread and seeing where you can go with that. According to the IMF, the International Monetary Fund, there are about 2 billion people who earn less than $2 US per day, and there's about 1 billion people who earn less than $1 per day. And I actually see greater applicability of this food pill for that crowd versus the people in this call, for example.
Yeah, and I'd add in on that with a question. I think this definitely has like me thinking this is definitely a big problem, and it hits on a moonshot problem. What I'm trying to wrap my head around is the product market fit and recognizing that this was done in just 3 weeks' time. What I'm trying to understand is the problem that you're trying to solve is making it more affordable for people to have a balanced meal, right? And why it's unaffordable today is because the meals become expensive, plus not having access to like what you should have or what you should be eating. So the app solves that problem of like what you should be eating. But when you take it back to like that affordability piece, like can you afford the pill or can you afford the food if the app tells you. The issue there is food wastage. The food becomes expensive at the table because 40% of it gets wasted in the distribution or the supply chain, right? And the solution that you're proposing starts with the same food. You air dry it to preserve it, and then you distribute it. So essentially what your solution is trying to do is replace the supply chain with a supply chain that has less wastage, right? And so what I'm curious about is, does that supply chain offer, do the unit economics work for that supply chain to kind of offset what happens with the traditional supply chain? Because if you're starting with the same food, which is going to cost you the same at source, so broccoli at source for you is going to be the same as for a farmer's market or someone distributing out of the farm. But then from there, if you're also bringing it back to the warehouse and then distributing all the way back to the consumer, you're going essentially through the same steps. So how do you compare that? And I know I'm throwing a very curveball at you, given that you've only done it in 3 weeks, but I want you to think about that thing.
If I can just sort of jump in on Saurabh's point there, it's an interesting potential for using food waste. So the stuff that restaurants and other institutions might throw out could become maybe an input into your dehydrated food capsule things.
Yeah, the financials was really a hard part in our solution because this is not something that obviously isn't done already. So it was hard to find data on that. But one of our ideas was to create those collective centers from the production to the retailers as close as possible in order to reduce costs. And also regarding the raw materials, we want to benefit from bulk purchasing and economies of scale. And regarding the wastage that you mentioned, this was one of our preliminary ideas. And in order to transport the raw materials, in order to air dry them and create all this process, we want to collaborate with the cold chain company, which is actually companies that keep the raw materials in temperatures so they're not harmed and wasted. So this is one way we're also partly dealing with the food waste as well.
Thank you so much, Rehan and Calypso. You can see from my background that I come from an organization that looks at grocery and food waste and quite a few things like that. In addition to your partnership with the UN, did you consider other partnerships with companies like Walmart or folks that could help with certain things or would be of benefit?
She's offering you guys take it up.
She's saying she wants to be a partner. Guys, we're cutting a deal right now.
Most of our focus was more on the idea than partnerships, but yeah, that would definitely be something I think all of our team are open to.
Good stuff. Okay, thank you.
Wonderful. All right, we're going to keep moving right along. Thank you guys so much again for answering those questions, for diving in so deep to this potential solution for a problem that's really important, as all the problems are that we've talked about today. We are into our last presentation. So, Elena, I know that you are taking this one. You're going to be our final presentation of this slot for our moonshots. And so you can come onto the stage to talk to us about Flight to Find. And whenever you're ready, you can start presenting.
Do you hear me? Do you see me?
We hear you, but your screen is still loading.
Okay, 1 second. Computer can be a little bit slow. So first of all, yeah, digest. My name is Lina, and my team and I, we're young scientists and innovators who strive to revolutionize search and rescue equipment with the help of Flight to Find company. August 2005. Hurricane Katrina brought massive destruction and flooding to the whole New Orleans, taking away lives of 1,008 people, causing an estimated $161 billion in damage, and leaving grief and despair in people's hearts. According to the International Disaster Emergency Events Database, globally, 80,360 people die each year because of natural disasters, such as hurricane, earthquakes, etc. And approximately 75% of deaths during an earthquake come from structural collapse, when people just can't get out of danger in time. With such situations going all around the globe, we must learn how to protect ourselves from natural disasters and how to improve the work of search and rescue operations. Right now, during emergency situations, ground-penetrating radar drones and smart robots are delivered into the affected area, where they scan the environment around them to detect survivors buried underneath rubble. Only after sufficient information is given, the location of the victims are transferred into the Common Operation Picture database, where the rescuers only start to develop the strategic plan. All these technologies are super helpful. However, they are not solving the main problem, saving people. With all the information that robots have gathered, rescuers have to do all the tough job by themselves, entering through the debris and risking their lives. During emergency situations, every second of the delay can cost somebody else's life. So there must be a technology that would allow us to, that will allow our rescuers to come to save people directly. This is where our solution come to help. Our flying exoskeleton will help rescuers to get into hard-to-reach places after disasters. And with the suit's wings, rescuers will be able to fly away from danger at any moment and safely transfer the victim with a carrier net from any place without worsening the injuries. The mechanics of the suit can be broken down into 3 parts. The flapping wing mechanic is composed of 3 gears, the wing structure and a motor. The motor, the power source of the skeleton, will actually give this machine the ability to fly, receiving energy from lithium-ion batteries and creating the speed needed to the wing to generate enough lift to hold the person. The second part of the suit, the main servo and its computer chip, are used purely for navigation and turning. The gears are used to move the wings up and down, connecting to the wing structure with a single bar. As the gears turn, the bar moves up and down with the gears motion and in a flapping motion as well. The gearbox is replicated on both sides of the suit to allow the wings to move independently. If one of the gearboxes moves faster than the other, it allows for the person to rotate sideways. But if both change the speed, then the suit will move up and down. When the servo is used, it turns the gear part of the 2 core wing supports, allowing for the average angle of each wing flap to be changed. This allows for the person to be able to rotate forwards and backwards. When the root servo is rotated, it affects how the force generated by the wing lifts the suit and pushes on different parts of the wings, effectively rotating the suit vertically. These 3 mechanics are all that is needed for navigation along the XYZ axis, providing a full range of motion, proving that exoskeleton is effective and has an ability to fly in a proper way. In addition to being technically feasible, this exoskeleton is very light and cost-effective to build. The materials that we are going to use are pretty cheap for the construction and much lighter than ordinary steel, which in sum will take approximately $400 to build. With such inexpensive production, we are planning to send it for a reasonable price with 50% margin. And we have an actual fast-growing search and rescue equipment market for that, with $114.9 billion revenue in 2020 and projected $132.3 billion revenue in 2027. Last but not least, our ideas got validation from real experts in the field of material science, mechanical engineering, and search and rescue operations team. Our mission, as a part of our mission, we want to reach people who are in danger because of natural disasters and save as many people as possible while bringing safety and security to the most vital areas of our lives. Thank you for your attention. That's all.
Wonderful. Thank you, Elena. You can stop sharing your screen and the judges will come up on stage, and I'm sure they have lots of questions for you about your idea.
I'll start us off. Love the idea. It's out there, but I like it. I think it's a really cool idea. Have you seen any proof of concepts out there? Has this idea been tested for real?
You mean the tech? Well, actually, we after searching through the internet for the aerodynamic suits that will perform similar functions, individualized suits, we didn't find anything. So we decided to design the concept from the scratch, receiving the validation from material sciences and mechanical engineers. And in addition to this, we decided to go even further and ask the customers, search and rescue operations teams, whether they like the idea or not, whether they are ready to use such equipment for rescue operations or not. And we received the validation from the director of the International Rescue Committee, stating that he stated that he actually is ready to use such a technology if we will receive funding to actually build it.
Okay, thanks.
So you're designing Batman here, right? As a in a sense, but using biomimicry, which is interesting. Is there a fail-safe on it? So if it goes wrong, there's what and have you put thought into, what if? Because obviously there's a tremendous amount of risk if I'm a rescuer using this machine.
Yes, of course. As for the case when the tech failed and the wings stopped working or something like that, we are planning to insert a parachute inside the mechanics so that the rescuer and the grounded person in the net will be able to safely dig down on the earth. And there are actually during when the problem occurs with the mechanics, a rescuer will get an automatic reply from the computer chip set into its helmet, where the information is gathered about the navigation. So basically, after that, the rescuers will automatically send the reply, source reply to their team, and the team will be able to safely meet them with the parachute landing.
I can share a quick comment and a question. From my previous work at Ericsson, I can validate that this is a problem that all the IoT companies are going after. In kind of like the whole search and rescue is one of the big use cases and focus areas for them, especially in areas like mining and where it's very dangerous for people to go in. So these kind of things can go in and help those missions. What I'm curious about is your thought process around picking this particular design or approach to the solution, because if in terms of feasibility in the next few years, there are drones, there are automated solutions that are trying to replace putting humans in those dangerous considerations. And so what was your thought process in kind of taking an approach where you're augmenting the capabilities of a human person versus putting a fully automated replacement in those situations?
Yes, you're absolutely right. And I totally agree with you. Because as you previously said, the field of search and rescue operations are evolving very fast. And I truly believe that the idea of putting a robot instead of person for the rescue operation is really good. But right now, we don't have such an ability. And even though this is the Moonshot projects, we still have a problem securing the lives of our rescue team during the rescue operations. So this is our main focus during this project. But as the times go and our project will receive support and funding, we will be able to develop the prototype of the exoskeleton and the exorobot that will fly and substitute the real rescuer.
Sounds great. Thank you.
Thank you.
Awesome. Does anyone have any final comments before we do some deliberations?
I was just going to say, Elena and team, well done. Super thorough, very detailed. Love the breakdown of actually the cost of the product itself as well. So very well done, given the short period of time you're also given for the Moonshot project.
Thank you so much. Thank you.
Wonderful. Thank you, Elena. Thank you, everyone, for presenting all of your ideas. I bet the judges' brains are just kind of having steam coming out of their brains because they're just all different. Trying to wrap your head around so many different problems and so many different solutions is a lot. But we are going to go into the judging room and deliberate, talk about who was the best presenter, who did best overall, who had the best technically deep 10x thinking idea. And then we will be back and let you guys know what we decide. In the meantime, Harrison will be here with some music playing. It is being live streamed. So if you guys do want to chat, feel free. Just know that we are on YouTube. There's only about 20 people watching, maybe some of your parents. So feel free to hang out here and we'll be back soon, probably in about 10, we shouldn't be any longer than 15 minutes, but I'll let Harrison know when we're back so that you guys can take a break, get a drink, go to the washroom, well-deserved. Thank you again, everyone. You should be very proud of what you guys presented today and we'll be back soon. And
awesome. To echo that, yeah, for those of you who presented while the judges are kind of heading out here, sure, this feels like a bit of a release of energy. So yeah, go if you need to go run to the washroom, do whatever. We're just going to play some music. If you want to chat, you can. And like Jenna said, the judges will be back in 10 minutes, but make sure you're here. You obviously want to hear who won all these different awards. So stick around, more to come.
Think about it, there must be higher life down in the heart, hidden in the stars above. Without it, life is wasted time. Look inside your heart, oh, look inside mine. Things look so bad everywhere. In this whole world, what is fair? We were blind, we tried to see. Falling behind in what could be. Bring me a higher love. Bring me a higher love. Oh. Bring me a higher love. Where's that higher love? I keep thinking of worlds turning. We're just standing on, facing my fear and standing out there alone. Yearning, and it's real to me. There must be someone who is feeling for me. Things look so bad everywhere. In this whole world, what is fair? We were blind, we tried to see. Falling behind in what could be. Bring me a higher love. Bring me a higher love. Oh. Bring me a higher love. I could rise above on a higher love. not in love. One more. Did it frighten you? How we kissed when we danced on the light up floor. On the light up floor. But I hear sounds in my mind. Brand new sounds in my mind. But honey, I'll be seeing you wherever I go. But honey, I'll be seeing you down every road. I'm waiting for it, that green light. 'Cause honey, I'll come get my things, but I can't let go. I'm waiting for it, that green light. Oh, I wish I could get my things and just let go. I'm waiting for it, that green light. I want it. Sometimes I wake up in a different bedroom. I wake up in a different bedroom, baby. I whisper things, the city sings them back to you. The city sings them back to you, back to you. Well, those rumors, they have big teeth. Oh, they write you that you said that you would always be in love, but you're not in love. One more. Did it frighten you? How we kissed when we danced on the light up floor. On the light up floor. But I hear sounds in my mind. Brand new sounds in my mind. But honey, I'll be seeing you wherever I go. Everywhere I go. But honey, I'll be seeing you down every road. I'm waiting for it, that green light. 'Cause honey, I'll come get my things, but I can't let go. I'm waiting for it, that green light. Oh, honey, I'll come get my things, but I can't let go. I'm waiting for it, that green light. Yeah, honey, I'll come get my things, but I can't let go. I'm waiting for it, that green light. Oh, I wish I could get my things and just let go. I'm waiting for it, that green light. I want it. I wish Tracy Chapman was my friend. She would know exactly what to say. Beginnings always hide themselves in ends. At some point I will be okay. I got high when I met you. I got high to forget you. I feel pain, I don't want to, but I have to. Yeah, I have to. If I wanna move on, move on, move on, move on. If I wanna move on, move on, move on, move on. If I wanna move on, move on, move on, move on, move on, move on, move on. If I wanna move on, move on, move on, move on, move on, move on. Went to see some shaman in LA to hear some things I wanted to hear. Everyone just wants to feel good. Everyone just wants took my breath away. Moving slowly through westward water, over glacial plains, and I walked off you. And I walked off an old me. Oh me, oh my, I thought it was a dream. So it seemed. And now breathe deep, I'm inhaling. You and others stare in between. Leave me be, I'm exhaling.
I look too good to be alone. My house clean, my pool warm, just shake smooth like a newborn. We should be dancing, romancing in the east wing and the west wing of this mansion. What's happening? I ain't playing no games. Every word that I say is coming straight from the heart. So if you're trying to lay in these arms, I'ma leave the door open. I'ma leave the door open. I'ma leave the door open, girl. I'ma leave the door open, open. That you feel the way I feel and you want me like I want you tonight, baby. Tell me that you're coming through. Ooh, you're so sweet, so tight, I won't bite unless you like. If you smoke, I got the haze. And if you're hungry, girl, I got the lace. Ooh, baby, don't keep me waiting. There's so much love we could be making. I'm talking kissing, cuddling, rose petals in the bathtub. Girl, it's jumping, it's bubbling. I ain't playing no games. Every word that I say is coming straight from the heart. So if you're trying to lay in these arms, I'ma leave the door open. I'ma leave the door open. I'ma leave the door open, girl. I'ma leave the door open. That you feel the way I feel and you want me like I want you tonight, baby. Tell me that you're coming through. La 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 la, I need you, baby. La la la, la 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 la, I got to see you, baby. La la la, la 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 la, girl, I'm trying to give you this. Hey, I'ma leave my door open. Leave the door open, baby. I'ma leave my door open, girl. And I'm hoping that you feel the way I feel and you want me like I want you tonight, baby. Tell me that you're coming
In the night while my body slept in my bed, my mind was running through the woods instead. 100 miles an hour in the fast lane, 100 miles an hour in my head. And vagabond dreaming takes me through the night, sipping whiskey by the river, living out of sight. 100 miles an hour in the fast lane, 100 miles an hour toward the light. See the curve in that river's bed, and I look at you when I see my friend. 100 miles an hour in the fast lane, 100 miles an hour to the end. key drum. And in the morning when the sun does come, 100 miles an hour in the fast lane, 100 miles an hour in the fast lane, 100 miles an hour till I'm done. Driving through West Virginia, and I've seldom been thinner, with that chip on my shoulder. And this past year I got so much older.
Well, everyone, we have been deliberating for what feels like centuries. There might have been some chair throwing. There may have been some screaming and yelling and debating. As you can tell, we've been gone for a little while, and I'm not kidding. When we even looked at our rubric, it was ties across the board with so many of your ideas. And that's not a joke. I will send you a screenshot of our rubric afterwards. And there was lots of debate about who we think is going to be getting our awards. But I can honestly say you were so impressive on so many levels that we debated having 7 awards so that each one of you could have an award. That's how good it was. And we're not joking about that. The judges are going to speak to their experience as well. And we are going to get into announcing our awards. So we have added 2 awards because we couldn't help ourselves. And so I will kick us off with the first one, and then the rest of the judges will go through the rest of the awards. Our awards are the Sci-Fi Award, the Social Impact Award, the 10X Thinking Award, the TEDx Presentation Award, and then the Best Overall. So just reiterate, the Best Overall is the one that was good in all of those categories. So they were the winners in many of them, and they will be the last to be presented. So I'm going to do a quick drum roll. If the judges, how about you guys unmute and you help me with a drum roll? Ready? Drum roll. For our first award, which is the Sci-Fi Award, you guys will probably know and love this. It is Flight to Find. Elena's group got our Sci-Fi Award. It was something so out there thinking that we could not help but give it some recognition for being a sci-fi solution. And so we love the creativity and the innovation. We had to give it a shout out in our judging. So they got the Sci-Fi Award. Next up, we are going to have the Social Impact Award.
All right, our Social Impact Award was also, all these very highly ranked, but the Social Impact Award, and social impact is what we should all be looking for in businesses. So that's this is a huge compliment. But the Social Impact Award goes to Gymnestic for their efforts to create flood-resistant crops and solve some hunger challenges in the world.
Amazing.
Congratulations.
Congratulations. I'm actually going to see, my clapping is not working, my clapping sound effect. I'm going to work on it. And while we wait for the second award, or the third award that's going to be presented, which is our TEDx Presentation Award.
Awesome. Sorry, TEDx or Impact?
Yeah, the TEDx.
So me, right?
Yeah, exactly.
Sorry, I think we're still like swirling over all the awards we wanted to give, and we're like, okay, we're ready to go. We want to give another award and another award, and another award. So for TEDx, we're really happy to give this award to Team Cosmic. So Minghao and Charlene, really well done. Your presentation was super impactful, beautiful storytelling, and we really took away some core messages there. So very well done. Congratulations.
Wonderful. And our next award is our 10X Big Impact Thinking Award.
So the thinking that we liked, there was a lot of debate on this because there's a lot of good thinking going on throughout all the projects, clearly. But the forward thinking, the forward positioning, and we certainly hope that the technical aspects can be worked out, and we'll see this thing come out for real. So the 10X Thinking Award will be the robotic trees and Repairx.
Yeah, that's better than emojis, right? That's better. Yeah, I wish we could all be in person so we could be giving a standing ovation. Wonderful. Awesome. And then finally, we have one award left, right, judges? And it is our best overall, is our last award to be given.
Awesome. So best overall, very, very, very difficult to find one amongst all of you, because all of you did great with the three aspects we were looking at, which was the vision, how far out the thinking was, the feasibility, the technical depth, how much did you do the research on it, and then the presentation and storytelling. And so the difference was just razor thin as we kind of figure out which one had all three. And the overall award goes to Repairx, team 1. I hope I got the name right for the team. And they had all the three. They had all the three things, and I just want to say, like, all the other 6 teams, they were also right there. So kudos to all of you for all your effort in the last 3 weeks.
Thank you, everyone. Thank you, judges, for your wonderful deliberation. Again, you guys, it literally, our rubric was tied across the board. So it was so close. And for any of you guys who did not get an award, just know that your work is very well recognized. And the words that were first out of these judges' mouth was, I can't believe that they are in high school. We were not doing this when we were their age. And we need people like you who are thinking and innovating, because it means that the problems that exist in our world, there's potentials to solve them. And you guys are the keys that are going to unlock that. And so it was very cool to talk with the judges. Their minds were spinning, and it was a very cool conversation. We talked, and they all want to spend at least an hour with you, going in more depth about your idea. That's how interested they were, and that's how much information that you gave them. So with that, that is the end of our first Moonshot presentations. The overall winner does get TKS swag, and so we'll be reaching out to you to get your addresses, to get some TKS swag. And judges, do you have any final comments before we send everyone off from this Moonshot?
Just a super great effort all around, and I think I was the one who commented, when I was in high school, I was not doing this. There were points in my university career, the later part of my university career, where I was touching on some of the stuff that you guys had presented. So very, very impressive, and the future is looking pretty good. Thank you, everyone.
I'll just say one quick thing. I'm leaving very, very, very inspired. So thank you so much for having us.
Yeah, actually, Sohrab said he got more energy from you guys than his morning coffee. That was a quote as soon as we got into the judging room. And that's a big coffee. Caffeine has an effect, and you guys had a bigger effect than even caffeine did. Awesome. Well, before we go, judges, I really want to say thank you. Everyone here on the call, if you guys can just give a round of applause for our judges. Such valuable input, and thank you for spending your Saturday with us and with all the teams here on the call, and just giving them your attention, your questions, your encouragement. I know it means the world to them, and hopefully this is a moment that people can look back on when they look back on how they pitched their first idea, when they're successful 20, 30 years from now, and you're a part of that story. So thank you for being here with us. And I mean, you guys can also disagree with me, but guys, you have a huge opportunity. You know these judges now, they know you. So reach out, connect with them, make sure you stay in contact with them. They're wonderful wealths of resources, experience, and knowledge. And they obviously care because they're here today with you guys. So make sure that you take the advantage of that and thank them personally as well for coming. For everyone here, I hope you enjoy the rest of your Saturday. It was a very well time spent. And so thank you, everyone. Harrison, if you have anything to say before we go off, really appreciate everyone and all the effort that's gone into this.
No, nothing to add. Echo everything. Judges, thank you. Obviously, for those of you who presented today, also thank you for putting in all this effort. And I hope you guys reflect and really think about the experience you had over the last 5 weeks. And I think this means a lot. The judges are giving you guys a lot of positive reinforcement here, I think, for this work, and excited to see where this goes. But that's it. Enjoy the rest of your Saturday. For those who want to come this afternoon to see our last Moonshot presentations. And then what are we down? I think we're down to like 4 weeks left of TCAS, guys. So this is it. Final stages. And we'll see you guys this week. And of course, again, next week, back into our regular sessions and our regular times. And we'll see you guys there.
Awesome. Thank you, everyone. Have a great weekend. Bye.
Thank you so much.
Thank you again, judges. Really appreciate your time.
Thank you so much for this.
Bye.